While at the Orlando HamCation this year, I was fortunate enough to get to spend some time with FlexRadio discussing the Aurora. If you're not familiar with the Aurora, this is an 18-pound, 160 to 6 meter HF radio that can run 500 watts key down or 200 watts on 6 meters and won't even break a sweat. The Aurora is 80 to 90% efficient. By contrast, a typical HF transmitter is only around 40% efficient. It includes an integrated antenna tuner and power supply and pulls only 6 amps from a 120 volt circuit. Since the Aurora is 80 to 90% efficient, it draws significantly less power, produces less heat, has a smaller heat sink, and can be put in a smaller box. Join me today as I talk to Tony, K1KP, who developed the idea of polar modulation, which is the foundation of the Aurora, Steve Hicks, N5AC, FlexRadio CTO, and Gerald Youngblood, K5SDR, the founder of FlexRadio.
Hey everyone, it's Michael at DX Engineering. I'm here this morning at FlexRadio with Tony, K1KP, who's kind of the developer of everything Aurora. And so I'm really kind of excited to talk to you, Tony.
Hi, Mike. Good to talk to you this morning.
Tell us a little bit about the background of how all this got started and how all this got off the ground.
Well, I originally started to get the germ of an idea back in the early 90s. At that time, I was into restoring boat anchors. And when you restore boat anchors, one of the things that you just about have to do is get onto AM. And I was on AM on 3885, and I heard a lot of good old boat anchor radios on there. And I also heard some Class E rigs. So some of the guys in New England and maybe other parts of the country were building Class E rigs for 80 meters. And they were pretty simple to build for AM. And they're extremely efficient. And you can get great power out of them. And I thought, gee, that would be a great idea if you could do that for sideband. And I kind of filed that idea away. And then fast forward to 2013 when I retired. At that time, I was president of YCCC, Yankee Clipper Contest Club. And before a meeting, I had lunch with a friend of mine, Brian, K1LI, and he had sort of similar thoughts along the same lines. And so we agreed to kind of get together and work on the project just as kind of a fun thing for a couple of retired guys to do. And we worked on the project for about 5 years. We first did a proof of concept where we made a little radio literally on a breadboard that made 40 watts on 40 meters, and it was a Class E final. And then shortly after that, we wrote a QEX article, which we titled The Polar Explorer, which was a takeoff on the polar modulation technique and also the fact that this was kind of a researchy thing for us. And a little while after that, after we'd worked on it for about 5 years, Brian kind of decided he wanted to go in a different direction, and so I was pretty much on my own. I saw that it had the potential to make a major change in ham radio transmitters. And I was interested in commercializing it because I knew that it would take a commercial success to get it into the mainstream. A QAX article wasn't going to get it into the mainstream. And so I was on my own, and the choices were either form my own company or partner with another company. And I hated the idea of forming my own company. I'm not a manager, I'm not a CEO, I'm not a bean counter, I didn't want to do any of that stuff. And what I really wanted to do was partner up with another company. And Brian and I had tried to pitch the idea to a couple of US ham radio companies without much success. And so I decided that the way to do this was to pack it all up, make a road show out of it, take it to Dayton in 2019. And it was kind of a last minute thing. I had like one table in a tent outside. I had a lot of help from some friends that helped me get there with all my stuff. And I set up my little shop and gave my elevator speech. And on Saturday afternoon, Steve Hicks from FlexRadio came by, and he listened to my little 30-second spiel, and he instantly got it. He understood both how it worked and what the potential was. So from that point, I went down to Austin and visited with Flex, They looked at the technology, and we came to an agreement, and we basically started a working arrangement. We've been working on the project for ever since 2019, and the result is the Aurora transmitter, which is right here. And basically, the Aurora transmitter is a totally self-contained radio. It has 500 watt output on HF and 200 watts on 6 meters. This one here is running key down into a dummy load. The radio includes a built-in antenna tuner and a built-in power supply, and the whole radio weighs 18 pounds. So you can take this radio, throw it in your carry-on, fly to the Caribbean, plug in the line cord, an antenna, and a microphone, and you're on the air with 500 watts on a Caribbean island. So it's been a long journey, but I think a very rewarding one, and we're all really proud to introduce this radio. We introduced it in Dayton, and we are currently shipping radios, and we just looking forward to turning over the industry a little bit.
So now I'm here with Steve Hicks, who's the CTO of Flex Engineering, and Steve's going to talk a little bit about the radio itself and kind of what makes it all purr.
Yeah. So we have 4 basic models. We have an AU510, and the AU510 has one ADC in it, which allows you to listen to one antenna at a time, and then you can put up to 2 receivers on that. And it comes either with the front panel or without. So we have a lot of customers that enjoy placing the radio at a remote location where you don't need the front panel, and you can use a Maestro or a computer to access it remotely. So that would be an AU510M if you want the front panel on it. And then we have an AU520, which has 2 ADCs in it, lets you listen to 2 antennas at once, do diversity, as well as have up to 4 receivers. And the really great thing about this radio is the size, weight, and power reduction that comes with the Polar Explorer technology. So if you look at what we've done, we've taken the transmitter, the receiver, and antenna tuner, everything, and packaged it into one box. And this box is only 18 pounds. And if you were to go and look on the market at a competitive solution, it's around 47 pounds. So it's a huge reduction, and that opens up all kinds of possibilities. So you could take this, if you wanted to, carry it up to the top of a mountaintop and run 500 watts if you wanted to do that. It also opens up a lot of other opportunities for us in other markets as well. If you think about it, the size, weight, and power that's caused by the inefficiencies of today's power amplifiers is really one of the things that limits a lot of operations. So if you thought about taking a trip with the family to an island and doing a de-expedition on that, and then you started thinking about, I'm going to carry a 1500 watt amplifier and all that with me, it just becomes unreasonable. You just don't want to do it. But something like this you can put in a carry-on and take with you, and it's very easy to use that way.
And this is something you can plug in with 120 volts and get 500 watts out of it.
Right.
Most amplifiers today, you can't plug into 120 volts and get 500 watts out of it.
That's right.
You're going to run at reduced power, 200 or 300 watts. So this is really amazing what it's doing. The efficiency of this thing is 80% efficient.
It's
right?
80% or better
80%.
efficient,
A typical ham radio is 40
to 50, somewhere in there, yeah.
So, and this radio is barely warm, and it's running 500 watts key down. So that's just amazing.
Yeah, it's hard to describe till people come up and actually put their hands on the radio and feel it. And it's cool. It's cold over here, and it's a little warm back here. Mm-hmm. And we have a load over here that's,
that's quite
piping
warm.
hot. So yeah.
Yeah. All right. Awesome. Steve, thank you very much.
Yeah, thank you.
Now I'm here with Gerald K5SDR. He's the founder of FlexRadio. Let's talk about kind of the history of FlexRadio and where you've all come from and how you got here to where you are today.
Well, FlexRadio back in 2003, which is 23 years ago, believe it or not, was the first on the market with a true software-defined radio. Everything was superhet prior to that day. And so it was an experimental project that accidentally became a company. It was just purely a hobby project. Like Tony wrote a series of articles, wrote four articles for QEX, and about my journey of studying how software-defined radios work, how to take software on a PC with a sound card and convert that through some RF hardware into a transceiver that actually worked, and actually worked better than the existing systems because it was so much quieter. And so then I was interested in, is there a market for this? So I came to Dayton HamCation in 2003, or actually 2002, and showed it off. I announced it and thought I'd get maybe 10 orders. I got 50 orders the first week, 500 the first year, all built on the kitchen table with kids coming home from college and getting parts. And so FlexRadio has evolved from that. And, but in the early radios were direct sampling using a PC, direct conversion, down to a low IF. In 2013, we started over with a clean sheet of paper. And we said, we're going to build the radio of the future, hardware and software. And that was the genesis of the Signature series, which was a 6700, 6500. And in that, we directly sample at the antenna. And so that was a revolution too, to start that. And that's put us into applications in the military and commercial as well, because HF is now important again. Because what happens on a day without satellites? Right. So that's really brought us in the mainstream. When I heard Tony's pitch at Dayton, the same time Steve was talking about, I immediately understood what he was talking about, because I had been studying doing linear amplification with nonlinear components called linear. Anyway, so I knew what Tony was talking about. I knew the basic math of what he was talking about, but nobody had implemented it in hardware. And as he said, components now were becoming capable of doing this at these frequencies that we're talking about here. So I immediately saw there was a marriage between the architecture we already had and the amplification capability that he had. So this radio is direct digital to RF. Even at the power transistor, it's digital. It's a switching, effectively a switching power supply that's controlled by the signal processing in the radio. So like Steve, I immediately saw the capability, understood it. It is non-trivial to do what is done here. The years that it's taken to do this, we're solving a myriad of problems to make it so you could actually produce it.
So this was a 6-year journey just to get this to market.
That's right? Correct. From the time we signed up with Tony in a partnership, it was 6 years. And there was a learning project all the way. We actually did some initial testing of his unit, and we came up with a punch list of things that you have to go solve. He went and solved those. Then we found more things that had to be solved. Actually, just to produce it reliably is non-trivial. So Tony's been a great partner. He jumped in and became part of the company, just like part of the team, and actually jumped into other projects. When this was in an ebb, he would jump into other projects. So he's been a great partner during this time. So really kudos to him for bringing this to us, for taking it through and bringing it to this point. So great partnership.
It's an amazing radio, and I have an 8600M at home right now that I've been playing with. It's just an awesome rig, and I think it's exciting times in ham radio right now to see how things are going to go forward, where they're going to go from here. But I appreciate your time. Thank you so much.
Thank you.
The Aurora is groundbreaking technology and is arguably the most significant advancement in amateur radio tech in the last 50 years. You can learn more about the Aurora and other Flex products on our website. I'll leave links in the description. Thanks for joining me today. I'm Michael K5SDR. We'll catch you on the next one.